For problem number 4, we're given that a woman is standing on a cliff watching a motorboat approach her through a telescope. We're given that the motorboat is traveling at 20 feet per second and the cliff is 250 feet tall. The value of the speed of the motorboat is dx dt. And it's asking us to find the rate of change of the angle of her telescope, which is going to be angle theta, and the motorboat when the distance between the base of the cliff and the motorboat is 250 feet. We are writing this as negative 20 feet per second because we have to know that the distance between the motorboat and the shoreline is decreasing, so we're going to use a negative value. Another value that we're given is that x is going to be 250 feet, y is equal to 250 feet, and we know that when two legs of an isosceles triangle are equal, the only possible value for angle theta is going to be 45 degrees, and that will come in handy later. So to find the rate of change of the angle theta when the motorboat is 250 feet away from the shoreline, we have to come up with a general equation to find the value of theta so that we can derive it. So our general equation is going to be that our tangent of the angle theta is equal to x over y. And here we're given that y is equal to 250 feet because the cliff is 250 feet tall. So we can rewrite that as x over 250 feet. And that's going to be our general equation that we can now derive. The derivative of tangent we know is secant squared of theta multiplied by the derivative of theta with respect to time, because that's chain rule, equal to the derivative of x with respect to time divided by 250 feet. And to simplify this, to get d theta by itself, we rewrite that as d theta dt equal to 1 over secant squared theta, because we divide both sides, times 1 over 250 feet times derivative of x with respect to time. To plug in all of our particular info, we can do all that now. So we plug into our equation d theta dt equals dx dt, which is negative 20 feet per second, multiplied by, we know that 1 over secant squared theta can be written as cosine squared theta, and we know that our only possible value for theta is 45 degrees. So we multiply negative 20 feet per second by cosine squared of 45 degrees, all divided by 250 feet. We have to solve for cosine squared of 45 degrees. We know that the cosine of 45 degrees is root 2 over 2, and when we square that, we get 1/2. So negative 20 times 1/2 gives us negative 10 divided by 250 feet, which will equal out to negative 0.04. Our feet cancel for units, and we're left with radians per second. So we know that the angle of her telescope is decreasing by 0.04 radians per second when the motorboat is 250 feet from shore.